Hello students, I hope you are fine and doing well in your studies. Students, today we are going to start from where we have finished in the previous class. In this session, we will study the basic fundamental of this chapter and we will do some basic example also. So students, let's start with the chapter itself.
Students, now we are going to study properties of argument. Property number 1. Argument of z1 into z2 is equal to argument z1 plus argument z2 plus 2k pi, because 2k pi is the general form. Got it? And principal argument can be obtained by this system. Now students, we are going to understand that how this argument comes. Let z1 is equal to r1 e to power iota theta 1. Now what is the argument of z1? It is theta 1. And let z2 is equal to r2 e to power iota theta 2. And you can write argument of z2 is equal to theta 2. Now we are going to find z1 into z2. It is also a complex number and it is r1 into r2 e to power iota theta 1 plus theta 2. Now we can write argument of z1 into z2 is equal to theta 1 plus theta 2. What is the theta 1? It is argument z1. And what is the theta 2? It is argument z2. So we can easily find property number 1. Similarly, we are going to find z1 upon z2. It will be r1 upon r2 e to power iota theta 1 minus theta 2. So we can write argument of z1 upon z2 is equal to theta 1 minus theta 2. So it is equal to argument of z1 minus argument of z2. This is property number 2. Property number 3 is here, argument of z to power n, and it is equal to n argument z. For the property 3rd, let z is equal to r e to power iota theta. Then what is the value of z to power n? It is r e to power iota theta whole power n. Now simplify it. It is r to power n into e to power iota theta n. So now if we are find the argument of z to power n, then we can write it is n theta, where theta is the argument of z. So we can write it is n times argument of z. So property 3rd is proved here. Now students, what is the property number 4? If argument z is 0, what is the meaning of argument z is 0 or pi? Then z is real, because argument 0 or pi lies on real axis. For this side argument is 0 and for this negative side argument is pi. And as we know, on real axis imaginary part is 0. So complex number is purely real. Property number 5 is here, argument of z upon z bar. By the property we can write it is equal to argument of z minus argument of z bar. As we know, if complex number lies in the first quadrant, then their conjugate lies on fourth quadrant. If argument of a complex number is theta, then the argument of conjugate of that number is minus theta. So we can write it is argument of z minus times argument of z. So we can easily simplify it is twice of argument of z. So we are going to write here argument of z upon z bar is equal to twice of argument z and generalize it. Similarly, if argument of z2 upon z1 is theta, then argument of z1 upon z2 is minus theta, and generalize here also. And argument of z bar is equal to minus times argument of z. Students, property number 9 is here, argument of z minus z bar. Let z is equal to a plus iota b. Then z bar will be a minus iota b. What is the value of z minus z bar? It is 2 iota b. It is purely imaginary number, and as we know, the argument of purely imaginary number is equal to plus minus pi by 2. If b is positive, then it is plus pi by 2. If b is negative, then it is minus pi by 2. So we can write argument of z minus z bar is equal to plus minus pi by 2. Property number 10 is here. Let z is equal to r1 e to power iota theta 1. Then what is the value of minus z? Minus z is minus r1 e to power iota theta 1. What is the value of argument z minus argument of minus z? Argument of minus z, if z lies in the first quadrant, then minus z lies in the third quadrant. If z lies in the second quadrant, then minus z lies in the fourth quadrant. Like this, if it is an Argand plane and z is here, then minus z is here. And we can easily find the argument of z is theta, then the argument of minus z is minus pi plus theta. If we are going to subtract these two, means argument of z minus argument of minus z, then it is equal to theta minus minus pi plus theta. Now simplify it, it is theta minus and plus pi minus theta, and it is equal to pi. And for this side it will comes minus pi. So we can easily say that argument of z minus argument of minus z is equal to plus minus. Students, what is the geometrical meaning of algebraic operation? What are the algebraic operations? Addition, subtraction, multiplication and division. And here we are going to study geometrical meaning of these algebraic expression. First, let z1 is equal to x1 plus iota y1 and z2 is equal to x2 plus iota y2 be represented by the points p1 and p2 respectively here in this diagram. Then z1 plus z2 is equal to x1 plus x2 plus iota y1 plus y2 is represented by the point p, where OP1 PP2 is a parallelogram. And similarly, z1 minus z2, or you can write z1 plus minus z2 is represented by the point Q as shown in the vector notation. Z1 plus z2 is equal to OP1 vector plus OP2 vector, and it is equal to OP1 plus P1P and is equal to OP vector. And z1 minus z2 is equal to OP1 minus OP2 vector. OP2 is equal to minus OR. So we can write OP1 plus OR vector and it is equal to OQ vector. Means sum of complex number is represented by OP vector and difference of the complex number is represented by OQ vector. Point number second, how we can represent a conjugate. If z is equal to x plus iota y, then conjugate is denoted by z bar and it is equal to x minus iota y, which is the mirror image of z along the real axis. What is the meaning of this? If complex number lies in the first quadrant, then their z bar lies in the fourth quadrant. If complex number lies in the second quadrant, then z bar lies in the third quadrant. Now we are going to note it down this property in the note first. If z lies in the second quadrant, then z bar in the third. If z lies in the first, then z bar in the fourth quadrant. Point number 2. If z1 is equal to x1 plus iota y1 and z2 is equal to x2 plus iota y2, be represented by point q1, it is the x1 y1, and point q2 x2 y2 respectively, then z1 into z2 is equal to x1 x2 minus y1 y2 plus iota x1 y2 plus x2 y1 is represented by the point P, which is shown here. This is the geometrical representation of product of the complex number. Now we are going to explain it. due to similar triangle, we can write OP upon OQ1 is equal to OQ2 upon OL. That is, OP upon R1 is equal to R2 upon 1. Then we can find OP is equal to R1 into R2. And we can find also angle LOP is equal to theta 1 plus theta 2. So we are going to write down this complex number, means OP complex number, which represent the product of these two complex numbers Z1 and Z2, and this is equal to R1 into R2 cos theta 1 plus theta 2 plus iota sin theta 1 plus theta 2. Here modulus of Z1 into Z2 is equal to R1 into R2, and argument of this complex number is equal to theta 1 plus theta 2. Students, now we are going to construction for the point representing quiescents, means Z1 upon Z2. Figure is here, Q1 is here, Q2 is here, and here this P represent the Z1 upon Z2. From the similar triangle, we can write OQ1 upon OQ2 is equal to OP upon OL, and this implies R1 upon R2 is equal to OP, means OP represent the R1 upon R2. And this OP is representing Z1 upon Z2 here. This is the geometrical representation of division of the complex numbers. Students, now we are going to study the triangle inequalities. In any triangle, sum of any two sides is greater than third side, and difference of any two sides is less than third sides. Here is a triangle. Suppose it is a x-axis and it is a y-axis, and we are creating a triangle here O, A and B. This is a AB line and this is the triangle OAB. Let it is the Z1 and it is Z2. Then this represents Z1 plus Z2. Now we are going to find the length of OA, it is mod Z1, length of AB, it is mod Z2, and resulting length of OB is mod of Z1 plus Z2. Now we can say that in this triangle, sum of two sides, means Z1 plus Z2 should be greater than Z1 plus Z2 whole mod. Here equality holds if points are collinear, means position vectors representing two complex number Z1, Z2 are parallel. And similarly, we can find that what is the Z1 minus Z2. If it is a x-axis and it is a y-axis, a vector or a complex number is represented by OA, and this is another complex number. We are going to write it is Z2, then minus Z2 will be like this. This is the minus Z2. Now we are going to draw a triangle here, and this triangle represent, let it is the Z1 and it is minus Z2, then the resultant will be Z1 minus Z2. Now we are going to take the length, this is the mod Z1, this is the mod of minus Z2, and this is the mod of Z1 minus Z2. We can write mod of minus Z2 is equal to Z2. So in this triangle OAC, we can write difference of any two sides should be less than third side, and this is the triangle inequalities. And here equalities hold if argument Z1 upon Z2 is equal to 0, means position vector representing two complex numbers Z1 and Z2 are parallel. And these are two most important property, and these property are called as the triangle inequalities, and we can use these properties in different questions. Students, now we are going to study application of complex number to geometrical application. First is the distance formula. Let Z1 is equal to x1 plus iota y1 and Z2 is equal to x2 plus iota y2 be two complex number represented by point P and Q on the argand plane. Then distance PQ is equal to square root x2 minus x1 whole square plus y2 minus y1 whole square. And similarly, we can prove that what is the value of Z2 minus Z1? It is x2 minus x1 plus iota y2 minus y1. And now we are going to mod of this complex number. It will be x2 minus x1 whole square plus y2 minus y1 whole square, and this is equal to the length pq, which is obtained by distance formula. So we can say that mod of z2 minus z1 is represent the distance between 2 points z1 and z2. So what is the mod z? Mod z, it is the distance of a point z with the origin. Students, here we are going to solve some questions. If z1 and z2 are two fixed points in argand plane, then find the locus of point z in each of the following case. First case is here. What is the meaning of z1 minus z2? Let it is a point A with the affix z1 and a point B with the coordinate z2. Okay. Then what is the value of z minus z1? Let a point represented by z is here. Suppose a point is here, it is C, and coordinate is represented by z. Then we can write z minus z1 is equal to length AC, and z minus z2 is equal to length BC. Now it is given that AC plus BC is equal to, what is the value of AB? The value of AB is mod of z1 minus z2, and here it is given that AC plus BC is equal to AB. Then we can say that this point C lie on the line joining A and B and between A and B also. Then the locus of C is a straight line joining A and B. Question number 2. If Z minus Z1 is equal to Z minus Z2, let A and B are the 2 points, A and B having fx Z1 and Z2, and let a Z a point such that it lies on the perpendicular bisector of joining point A and B, then we can say this distance means that this point is P. This AP distance is always equal to PB distance, and here it is given that AP is equal to BP. So we can find that point P lies on this bisector, perpendicular bisector lines. So the locus of Z is a straight line which is the perpendicular bisector of line joining A and B. For the question number 3, let a point ABC like this. Point A is here, it is Z1. Point B is here, it is Z2. And point C is here, it is Z. AC distance is equal to mod of Z minus Z1, and BC distance is equal to mod of Z minus Z2. And here we can write AC minus BC is equal to AB. What it? Because it is AC minus BC is equal to AB. It is possible if C is lies on the line joining AB but away from the B, means on the right hand side of the B. The locus of point C is a straight line which is lies in the right hand side of B and joining the line AB. Students, now we are going to study point number 2, section formula. If point R divides the line segment PQ, where P and Q represent the complex numbers Z1 and Z2 respectively, and point R represented by Z, then the coordinate of R means Z can be obtained by internal division formula, and it is equal to mz2 plus nz1 upon m plus n. For external division, this coordinate can be found out by the formula mz2 minus nz1 upon m minus n. Similarly, we can find midpoint of the line segment PQ, it is z1 plus z2 upon 2, because for the midpoint the ratio is 1:1. It is the z1, it is the z2. The coordinate of this point will be z1 plus z2 by 2. Students, how we can find the area of triangle? If the vertices of a triangle ABC represented the complex number z1, z2, z3 respectively, then the area of triangle is the modulus of iota by 4 z1, z1 bar 1, Z2, Z2 bar 1, Z3, Z3 bar 1. This is the determinant. Students, slope of the line segment joining 2 points. If PQ represent the complex number Z1 and Z2 respectively in the argand plane, then the complex slope of PQ, it is Z1 minus Z2 upon Z1 bar minus Z2 bar. Students, you have to keep in mind this complex slope of line PQ. Students, now we are going to study condition of collinearity. 3 points A, B, C, whose affixes are Z1, Z2, Z3 will be collinear if there exists a relation AZ1 plus BZ2 plus CZ3 is equal to 0 such that A plus B plus C is equal to 0, where ABC are the non-zero real number and ABC are not all zero real numbers. Got it? This is the first way by which we can prove that ABC point are collinear. Second way is here, if the area of triangle ABC formed by Z1, Z2, Z3 is 0, then we can say that points are collinear. Third way is here, if slope of AB is equal to slope of BC is equal to slope of AC, then we can also say point ABC are collinear. And as we know, the complex slope is Z1 minus Z2 upon Z1 bar minus Z2 bar. This is the slope of AB, and slope of BC is Z2 minus Z3 upon Z2 bar minus Z3 bar, and slope of AC is Z1 minus Z3 upon Z1 bar minus Z3 bar. Students, now we are going to study the equation of a straight line. Let P affix Z1, Q affix Z2 be two given points in the argand plane, and if R, point R with affix Z be any points on the line joining PQ, then we have, means this system is like this. It is the P Z1, it is Q Z2, and R is here, and affix is Z. Then argument Z minus Z2 means slope of the line joining Z and Z2, this, and slope of the line joining Z1 and Z2 is same. So we can write argument Z minus Z2 is equal to argument of Z2 minus Z1. By the property of argument, we can write argument Z minus Z2 upon Z2 minus Z1 is equal to 0, because it is argument Z minus Z2 minus argument Z2 minus Z1 is equal to 0, and it is given here that argument Z minus Z2 is equal to argument Z2 minus Z1, because Z1, Z2 and Z are the collinear. And if argument of any complex number is 0, then this complex number is a purely real. And for purely real complex number, we can write Z is equal to Z bar, or you can say Z minus Z bar is equal to 0. And complex number is here, so it is the Z minus of Z bar is equal to 0. Now we are going to simplify it. It is the Z minus. By the property of conjugates, we are going to simplify it. It become like this, means Z bar minus Z2 bar upon Z2 bar minus Z1 bar. Now we are going to cross multiply it, and after then we can find the system like this: Z into Z1 minus Z2 bar minus Z bar, Z1 minus Z2 plus Z1 Z2 bar minus Z2 Z1 bar is equal to 0. And this equation also can be written as Z Z bar 1, Z1 Z1 bar 1, Z2 Z2 bar 1. All these conditions means first and second represent the equation of a straight line, because point Z is a general point and a relation which contains Z, Z1 and Z2 represent the equation of a straight line. So equation of straight line can be written as by equation number first and equation number second. If in equation first Z1 bar minus Z2 bar is equal to A bar, equation first is here, okay, then Z1 minus Z2 is equal to A, means this equation can be written as Z A bar minus Z bar A plus B is equal to 0. Here this setup is equal to B, and we know that this is the purely imaginary part. Here B is the purely imaginary part, and this is also a representation of a straight line. And here, if the equation third, this equation is multiplied by iota, it reduces to z iota a bar minus z bar iota a plus iota b. And we can write this equation like this: z a bar plus z bar a plus b is equal to 0. And this is the fourth equation, and this also represents the equation of a straight line. But here b is purely real. Keep in mind, in this setup, if minus sign is here, then b is purely imaginary. If plus sign is here and equation is like this form, means z a bar plus z bar a plus b is equal to 0, then this b is purely real because b is a purely imaginary, and after multiplying by iota, it will become purely real. So students, keep in mind that equation number first, second, third and fourth will represent a straight line in complex number. Students, here are example. Example number 1, 3z plus 3z bar plus 2 is equal to 0. It is a straight line because it is the form number 4. 3z minus 3z bar minus 6 iota, because here is the plus sign and here is the minus sign. If minus sign, then it is also a straight line because it is purely imaginary. But if plus sign, then here must be purely real number. And in example number 3rd, here is the imaginary part, or you can say purely imaginary number. So it is not a representation of a straight line in complex number. Students, to formula also written here, real slope of a line, it is the a plus a bar upon iota times a minus a bar. If equation of a straight line is like this, a z bar plus a bar z plus b equals to 0, then slope, real slope of the line is given by this, and complex slope of the line is given by minus a bar upon a. Students, distance of a point from a line is given here. Distance of a point P, Z1 from the line Z a bar plus Z bar a plus b is equal to 0 is given by Z1 a bar plus Z1 bar a plus b mod whole upon real part a whole square plus imaginary part whole square. It is the whole square here, keep in mind, and this is equal to Z1 a plus Z1 bar a plus b is equal to twice of mod of a. Students, here are condition for perpendicular or parallel lines. Let the complex slope of two lines be alpha 1 and alpha 2. For perpendicular lines, alpha 1 plus alpha 2 is equal to 0. If lines are parallel, then alpha 1 is equal to alpha 2. Because lines are here, a bar z plus a z bar plus k1 is equal to 0. B bar z plus b z bar plus k2 is equal to 0, where k1, k2 belongs to real number, are perpendicular if the complex slope of this is minus a bar upon a and complex slope of this line is minus b bar upon b, and by this condition we can write alpha 1 plus alpha 2 is equal to 0. Now simplify it, it will be a bar b plus a b bar is equal to 0. And these lines are parallel if slopes are equal, then we can write minus a bar upon a is equal to minus b bar upon b, or you can say a bar b is equal to a b bar. So students, please note it, line parallel to z a bar plus z bar a plus b is equal to 0 is given by z a bar plus z bar a plus lambda, means only this part can be changed in the parallel lines. And line perpendicular to this line is given by z a bar minus z bar a plus iota lambda is equal to 0, where lambda belongs to a real number.